Now that we've reviewed the 6000 from its start up to current production, we're going to review the installation and startup of a new system. The 6000 series is typically installed on the owner side of the pointing demarcation in the telco room of the building. An RJ71C routing block is installed and wired between the Model 6000D stack, an RJ21C block, and the subscriber's telephone. The 6000 series, excluding the Mini 6000, are based on a standard 19-inch 12-position cage. The cages come in three types. The system will come with a first cage that will either be an Econo cage or an M-Bus cage. The Econo cage is a 1 to 2 gate system. The M-Bus cage is for a 3 to 8 gate system. There also might be several stack cages, each stack cage holding up to 12 stack cards, each stack card serving up to 12 residents. This is a very basic wiring diagram showing an Econo cage Model 6000D. The RJ71C blocks are represented and showing the wiring going to the stack boards. This is a 2-gate system represented by the concierge and an entrance telephone. This also shows some wiring, very basic wiring for a control board and power ring board that is also present in every system. The system itself is either defined as an Econo system or an M-Bus system, strictly based on the main cage makeup. The Econo cage has an expansion potential of up to 2 gates, whereas the M-Bus has an expansion up to 8 gates. Both come with a power board, both have a control board. It's strictly this gate expansion that makes the big difference. The Econo cage can hold up to 8 stack relay boards in the main cage, whereas the M-Bus, because of the 8-gate potential expansion, can only hold 2 stack relay boards. Any additional residents that are served go into a dedicated stack cage that will stack above the system, depending on how large you need. Each stack cage can hold up to 12 stack relay boards. Each relay board can serve up to 12 residents. So these systems are always built in units of 12, rounding up to the next 12. The power ring board connects to a remote power supply via a cable. This board provides all of the power requirements for the entire system. The power ring board has 5 red LEDs. The top 4 will light up when power is applied. The 5th LED lights up when logic power is valid. Therefore, the system is working, talking to each other, wired correctly. So you won't get that 5th one lit up until everything is wired correctly. Do not switch on the power supply until all wiring is completed. Don't test it out. Don't check it out. Make sure it works. Make sure all the wiring is done before you flip that switch. If you look in the bottom left-hand corner, you can see the 4 LEDs, and that 5th one will light up as the call comes through. Just as your computer doesn't react well to sudden brownouts or power surges, the system doesn't either. It's highly recommended that you use an uninterruptible power supply rated at 450 amperage or higher. These are easily gotten in any kind of computer store and well worth the investment. The control board is the main brains of the system. It has 2 primary functions: general system control and system memory that includes an audit log. It supports a 1200 baud modem option and RS-232 interface for direct connect to a local terminal for programming and display purposes. The gateboard presents a standard telephone line wire pair to a designated location and allows a person to call anyone in the stack by dialing the relay number of the resident. There needs to be 1 gate card for every station. So if there's 3 stations, like a valet, a doorman, and a management office, there needs to be 3 gate cards, 1 for each one designated. Each gate board must have a unique address setting on the dip switches in the upper corner of the board. Towards the letter is an off condition. Away from the letters is an on condition. Each one has to be uniquely different. The stack board is used to route a resident's private telephone line through the gate station board. Stack boards are numbered in ascending order, starting with the board closest to the gate station board on the left and ending with the last stack board on the right. Each stack board supports 12 resident positions. So if there's 24 residents, expect 2 stack boards. If there's 25, expect 3. Each stack board has 2 LEDs, 1 red and 1 green. The green LED indicates interrogation is being performed on the board. The red LED, when lit, indicates that a resident's relay is active and the resident's service is being routed through the board to a gate station board. The shifting green LED will always be active when power is applied because the system is always interrogating itself. It's in a constant state of interrogation, so you'll always see those green LEDs shifting when power is applied. To find the stack position of a relay, go ahead and use the formula that's given on the installation form. For example, if you're trying to find the stack position of relay 7 on stack card 12, the answer would be 139. You get this by taking stack card number 12, subtract 1, that equals 11, multiply times 12, that equals 132, add 7, which is the relay number, and you'll get to 139. When installing the cages, the number 1 cage is best located at the bottom of the rack in a multi-cage system. We will mark the cages 1, 2, 3, etc. when they leave here so that it's clearly labeled when you get it on site. Stack the cages so there's minimal distance between them, and then daisy chain them together with the cable that we supply. The RJ71C block creates a means of attaching both the telco lines and a switching device, in this case being our system, to a subscriber's telephone. The diagram on the left shows some of the wiring techniques. The block should be installed within an enclosed secured area, preferably leaving enough space for the 6000D card racks, the frame, the cabinet, etc. Standard cable length for a system is 15 feet, which is what we standardly sell, though we do have 25 footers if it's requested and added into the system. These are a few RJ71C wiring suggestions that can be done. If you have any questions, we'd be happy to walk you through any wiring problems that you might come into. Make sure management is aware of the day of installation so that they can pass along to residents that they may experience a temporary loss of telephone service. This saves a lot of hassle and aggravation on installation day. Well, you've had all that hard work of installation. Now it's time to pay off by powering the system up for the first time. Go back and verify that all the boards are properly seated, everything's locked down, all the cables are correctly installed, and switch the power supply to on. Only allow about 30 seconds for the system diagnosis to complete. At this point, you should see a green LED on the number 1 stack board. That's the stack board on the left, closest to the gate board. That LED will come on, and it'll shift to the right, number 2, number 3, number 4 stack boards. It'll go in rotation 1 every second all the way through and come back to stack board number 1 again. It's a constantly interrogating system, so you're always going to see this shifting of that green LED, one to the next, one to the next. Here's a system that's in burn-in that's getting ready to ship. We go through a testing process through every system before it ships. You can see that green shifting light going through every board for interrogation to make sure that everything is functioning and working and talking correctly to each other. Well, the system powered up and checked out great, so now it's time for a resident call test. Go ahead and power the system back down. Attach a butt set or a standard telephone across the simulated telephone wire pair on the gate board. That's pins 7 and 8 at the top of the gate station board connector. Switch on the power supply. You're going to go back through the same sequence you just went through. About 30 seconds go by. The green LED on stack 1 will come on, then stack 2, 3. That same green sequence is going to go through. When you're satisfied everything appears to be working just as it did before, engage the butt set. At this point, you'll hear a simulated dial tone. Dial the resident position specific for the resident's telephone line you wish to test. If it's going to be the resident tied to the first stack position of the first stack board, then dial 101. Hopefully you have someone on the other end to answer. A red LED will light up on the stack board selected. You'll hear ringtone, verify you hear a clear voice answered, and then terminate the call. At that point, the red LED will go out. You will still have the green interrogations going through 1 through however many stack cards you have, because that's an ongoing interrogation, but the red light will go out as soon as you terminate the call. If you take a look in the upper right-hand corner, you can see the interrogation LEDs, the green ones flashing back and forth. As the call is initiated, the solid light comes on, the red LED on the stack card, and stays solid during the duration of the call. If you look in the bottom left-hand corner, you see the 5th red LED will come on as logic is applied and communication happens. The LED in the upper right-hand corner will stay solid during the duration of the call and terminate upon termination of the call. If you have a multi-gate system, keep that butt set in place. You're going to dial a 0, wait, in about 3 seconds a secondary dial tone will be heard. Now dial the logical address 0 through 7 of the gate board. Verify you hear a voice and hang up. Now your system's online and ready to go. As with anything new, training needs to happen. So we provide resident training cards or reference cards for all the residents in the building. If you need any more, give us a call. We'll be happy to send them out.
Thank you very much for sitting through our presentation. If you have any questions during installation or for system design, please call us in Corona, California for any kind of technical assistance, and we'll be glad to help. Thank you.